Krakatoa is a volcanic island situated in the Sunda Strait between the islands of Java and Sumatra in Indonesia. On August 26, 1883, Krakatoa erupted and in the next day, two-thirds of the island had collapsed under the titanic explosions. The explosion is estimated to be around the same as 200 megatons of TNT. The initial explosion ruptured the magma chamber, allowing seawater to contact the hot lava. This created a cushion of superheated steam that carried the pyroclastic flows up to 40 kilometers. These explosions unleashed huge tsunamis, killing more than 36,000 people and destroyed 165 local villages. The explosion alone was heard 3,000 miles from its point of origin, and the shockwaves were recorded on barographs around the world. The eruption shot 11 cubic miles of debris into the atmosphere. Krakatoa is a composite volcano and has formed gradually over time, when lava escapes through a fissure in the Earth's crust and spreads slowly, creating layers. These volcanoes are steep-sided and are typically tall. They are generally found near the convergent boundaries in the Earth's crust.
Earth is home to huge amounts of carbon, not just in the atmosphere and the oceans, but also deep underground. When volcanoes erupt, they release massive amounts of volcanic gas and ash into the atmosphere. Among these is carbon dioxide, a greenhouse gas. Eruptions are an outlet for the massive amounts of carbon residing deep underground. The CO2 emitted from these eruptions does contribute to the substantial amounts of CO2 in the atmosphere, but only on a very small scale. However, volcanoes are having a much larger effect on the atmosphere, but through a different method. When sulfur dioxide is converted to sulfuric acid and released into the atmosphere, it condenses in the stratosphere to form sulfate aerosols. These fine particles absorb heat radiated up from the Earth, thus warming the stratosphere. There are also some complex chemical reactions that take place on the surface of these aerosols. Nitrogen and chlorine species in the stratosphere are altered, and this effect, coupled with that of human pollution, generates carbon monoxide, which kills ozone.
In terms of possible solutions to the effect of a volcano, there are none, as the only way to deal with the volcanic ash is to stop the volcano from erupting in the first place. Maybe in the future we'll be able to terraform planets at will, but I'm fairly sure that's not going to happen anytime soon. So, if you can't prevent it, what can you do? Well, the best thing you can do is to prepare for the event. If you live close to a volcano, make sure you can evacuate quickly and under short notice. Based off the 1833 explosion of Krakatoa, the subsequent tsunami will be more likely to kill you than the falling ashes.